In the long, long, long ago, there was once a measure called the foot. It's a length about 30 centimetres long. You're probably aware of it a little bit. You might not be aware it came from a man called Henry's foot, King Henry, no less. I'm not sure which one of the 8 King Henrys it was, but that was where it came from. Next, along came some Frenchmen who were both Republicans, and it was during the French Civil War. So while they were about to get rid of their king, so the Republicans don't like kings. So they don't like this idea that we have a measurement based around a king's foot. So the French invented the metre, which is perhaps why the R and the E are the funny way around, because that's what French do. So this metre, it had nothing. They decided they're going to invent a metre as a unit of length, but no real idea about what it could be and what they could base the measurement on. So these Frenchmen came up with this idea. They thought about the world. How can we base this measurement based around something to do with the world? It doesn't base it on any person or human. And they thought about France for a bit. And they thought, well, you know what, if we can, in France, take a measurement of the night sky from 2 different points in France, then by using the magic of the cosine rule, we can figure out the angle between them by looking straight up and looking at the difference in the angles, using the radius of the Earth. We can actually figure out the length of a piece of land quite easily in theory. So they decided to make the length of 10 million metres the distance between the equator and the North Pole. That's the definition of a metre as it was originally founded a few hundred years ago by 2 Frenchmen who did not like kings and queens. So this is a really great idea. We'll just get our tape measure out and go between the equator and the North Pole and cut that up into 10 million pieces. They actually came incredibly close to getting the exact right value. I'll let you look it up independently. It's a fabulous story. Okay, so we have the degree. Now the degree is a lot like the foot in that we divide the degree effectively helps divide something up into fractions. The foot is divided into 12 inches, and each of those inches is divided not into decimals but into fractions of inches. So fractions and dividing stuff up is really popular amongst these old measures. And degrees, the reason why we use degrees is that 360 degrees has more factors than you can handle. In effect, we can divide a circle into half, a third, a quarter, a fifth, a sixth, and still have a whole number of degrees for each sector. Not a seventh, that doesn't work. But an eighth does, that would be 45 degrees. A ninth of a circle, that would be 40 degrees. A tenth of a circle, 36 degrees. 11th doesn't work. 12th of a circle would be 30 degrees. And so on and so on and so on. We can divide our circles up into lots and lots of fractions and still have a whole number of degrees. In effect, we like degrees if we don't have calculators. Now I want to tell you about radians, because a radian is another way of measuring an angle. Well, we don't use radians because we are ideologically opposed to kings and queens, so that's not the reason. Or because we have calculators now, so adding and subtracting angles would be no more difficult in degrees than in any other measure. So we're not picking up those things because it's going to make our life easier in some kind of palpable way. There is a reason though, and I do want to share that reason before we get started because I think it's important. At this stage, we use radians for one reason and for one reason only. we cannot differentiate when our measure is taken in degrees. So degrees does not work with differentiation. Degrees are man-made. There's no reason why 360 degrees should be the number of degrees in a circle. We must convert into radians first before we can differentiate. In this video, I'm not going to go through, or in this chapter rather, we're not going to go through any differentiation whatsoever. So it's going to feel a bit strange. All I want you to think of is that you are converting from degrees, which you're really familiar with, into radians, which you're not yet familiar with. So you're going to be working on becoming familiar with, well, what is 45 degrees in radians? What is 270 degrees in radians? And that's going to be, by and large, the big thing that you do in this chapter, is just familiarise yourself with the conversion between radians and degrees. And also there's a couple of little equations that you'll need to come to terms with as well.